Good morning.
Good morning, ladies and Will. Good to have you here today. We're going to start working on this set 9 through 16. And do you notice at 9 through 16 it says solve the triangle, but it doesn't really tell you how to solve it, does it?
No.
Yeah, it doesn't tell you how to solve it.
I don't give you no answer.
Sounds like a bad teacher. You know, do this. I'm not going to tell you how to solve it, just do it.
But to me, a lot of times that's what the good teachers do, because then you learn by exploring. Right?
Exploring the jungle.
Yeah, so exploring, and it's like my predecessor, Mr. Calvin.
Yeah.
Okay, Mr. Calvin's have, do you see where it says the truth?
Off the fairway.
The truth will set you free.
The truth will set you free, and then failure, Carmen, Kinsey, Kinsey. Okay, we're in the monologue section of the course right now. The truth will set you free. Failure is an unavoidable part of learning
Who said that?
that requires the courage to persevere and determination to make sense of the flaws. And so basically it's learning by exploring and learning through your mistakes and persevering through, right?
Who said the truth will set you free? Wasn't it like Martin Luther King?
The truth will set you free. Yes, Jesus.
Right?
Okay.
Donald
The
Trump.
truth will set you free. Is that in the?
I'll look it up for you.
Yeah, it'll be in the.
In the.
It's probably in the Bible.
When they're doing
Oh,
like
it might be the Bible.
I think it's the words of Jesus, or at least paraphrase of Jesus. Okay. So anyway, solve the triangle. I want you to go ahead and look at number 9 and tell me what you think about number 9, and try to solve it. Can you try to solve number 9?
John 8:31.
Oh, yeah, it's in the Bible. The truth people?
John 8:31.
Yeah. Ye shall know the truth, and the truth shall set you free. That's what it is. Yes.
Well, we have all of our sides.
Do we have the side?
How do we figure out the angle?
You gotta use formulas.
Inverse sine. Oh wait, are we doing cosine?
Yeah. If you have a side, what use is that? What application is that?
Can you do the word?
Oh, you can figure out the angle by using that formula we used yesterday.
Right.
Oh,
Uh-huh.
it's in here.
So let's go ahead and do
Square
that.
root of a squared.
Okay. We can't use law of sines because we don't have a known angle opposite a known side, right?
Square root
So
of
we cut the side. Yeah.
square root of a squared plus b squared.
So what we have is if we want this.
Times 8.
That's a
Okay,
little
thank you,
bit.
Chris.
It's a little bitty one.
Thank you, Chris. That's the right size of serving. That's what I want.
Hey,
I'm
brother.
not using you.
Hey,
Thank you,
brother.
Chris.
Hey, Chris.
Okay, what I'm going to do is I'm going to write this, and it sounds like you haven't really remembered the formula, so let's do this. Okay, it's C equals inverse cosine of C squared, which is 4 squared, minus A squared minus B squared over negative 2 times 1 times 5. So that is going to be our angle. And so we have this right here in our calculator. So in the calculator we have second cosine.
Wait, Mr. G, the one we did yesterday that we didn't do the inverse of cosine, what was that for to find? Where it's just
in
the
the
square root.
Let's see.
That's probably law of sines you're thinking of.
No, not law of sine. It was the cosine one. But
Oh yeah, you're thinking that if you're trying to solve for a side given an
so
angle.
it's for side,
Yeah.
not an angle.
Yeah,
Solve for side.
Every time you solve for angle, you have to do the inverse, right?
Yeah.
right, if you have 3 sides. So times 5 times 1. So we have, so this is it. And so we press this and when we get an answer of,
Wait. You got to put the negative 2 on top.
oh, I forgot the negative 2. Let me go ahead and try second enter.
Good catch, Will.
see if it allows me to get, I think I can fix it now. Thank you for catching that. I was too busy talking to people. Times 2, right? I'll just say times 2.
It's gonna be in our outfield, because our outfield.
So that should be good now, right?
Yeah.
0.
How does that make sense?
How does that make sense? I want you to look at that problem and think of it. People in 5th period didn't figure it out either.
It's unsolvable.
Like, why is it unsolvable? What do you notice about that?
Oh, I get it.
Because you
Okay,
can
so
draw a triangle.
The
Triangle.
B and C, right, if you have B is 5,
Uh-huh.
and C is 4, and A is 1, you can't have a triangle, you can't have something longer
Okay.
than 5 to make it a triangle, so it has to all be straight.
Okay, we'll figure it out. And that is, if you have this, you don't have, and he said it pretty well. You have this, say is 5, right? B equals 5. And say you have C equals 4. So here C is equal to 4. Is it possible, if this is a correct drawing, is it possible for these to join up?
Nope.
It is not. Okay, A equals 1. That's an impossibility.
No, that has to be more than 1.
Yeah, it would have to be more than 1 to make it work. And so what you have is, Will said it really pretty much exactly right. I'll call it exactly, I'll give him credit for exactly. What it is, you're looking at a line segment, aren't you? It's just collapsed down right to the base B. So that's going to be side A, and that's going to be side C. And so that's going to explain why you have 0, an angle of 0, right? So that's what that one is. So I appreciate you thinking about it, because nobody in 5th period got this. So, you don't get it? Okay. Okay, if I had a piece of paper, you would see. Katie? Okay, Kaylee. Do you see that this side and this side are equal to that side? Right, you see that, right? And so what that means is you can't, it has to be just plastered against this side here, because this would have to be, as Will said, greater than 1 to make a triangle out of it. So if we had a 5-inch piece of ruler and a 4-inch piece of ruler and 1-inch, and we put them together at the corners, this is the only way it could look flat against B. Does that make sense now? So it's just like, but it's really hard to conceptualize. So what I want you to do is work on look at number 10.
Yeah, no way that's possible.
So 10 doesn't work either. So answers for number 9 and 10 are not a triangle, right? So not a triangle. And then this one here, also not a triangle. Now what I want you to do, we don't have a lot of time left in class. What I want you to do is go do 11, we'll probably be able to do 11 and 12 today. Let's do that.
Yeah, let's do that.
We'll go to 11 and
Are we
12.
skipping 10?
No, 10 was done.
It is not a triangle.
Oh, it has
Same, right? So what do you have to have? What do you require to have a triangle?
3 sides.
3 sides? And what about the dimensions of the
A
side?
side is bigger than 1. A side is bigger than 1.
Well, no. You need to have your 2 shorter sides add up to greater than the longest side.
Okay.
That's what I'm getting at. And yes, Kinsey said you do need 3 of them.
Yeah, non-solvable.
So what I want to do is I want to call on a
Hold on, I think about
victim for number 11.
Not me, I'm already dead.
I just feel like you could get this one and three of them. Another one?
Yeah. You did on this one. Who?
Yeah.
What about that?
Jimmy, let's see, release one.
Okay, we have,
Do you subtract them all from each other?
Yeah. Yes,
we're going to get, looks like Emily or Kayla. It's Emily. All right, Emily, this is yours.
Alright, and like
Okay,
you.
hold on, hold on. I need it. Okay, so I drew a little picture.
Okay,
I like that.
so some kind of triangle like this, like something like this,
Yeah.
but with straighter lines than that, yeah. Okay, it's kind of non-Euclidean, so something like this.
And then,
So you had A over here equals 3.2,
yeah.
and this one here would be B equals 7.6, and C
6.4.
equals 6.4, okay. I don't know about this. You don't actually have to draw a triangle, but when I do it, I like doing it.
It just helps me.
It helps me too, that's the way I am. All right, go ahead.
So C equals,
So big C equals,
actually, that's how it is.
okay. So we take,
6.4 squared minus 3.2. Oh, wait. I guess-
yeah, this will be the same, right? 3.2 squared.
And then divided by 2 times 7.
Now, I'm gonna mention something again. I don't know if I've mentioned it earlier, but I think you're gonna be okay here no matter what you do, because relative to the sides, this C is pretty big. But my recommendation in general is to solve for the biggest one first, because you're less likely to get in trouble with the whole ambiguous law of size. But I think in this case, C is gonna be big enough that you're probably going to be okay. Go continue.
Okay. And then,
Angle C is equal to?
let me put it. That's the only one you find. 56.226.
Degrees, right? Okay, and what was the next one you solved for?
I guess, I was doing it on with you, so I guess we can solve for A.
Yeah, A would be, that's my recommendation. Go for the smallest one first, because that's going to have less chance of
Do you
getting in
have to
trouble.
do that equation again, or could you do that one equation?
I use sine now, right?
Yeah.
Now, yes, you could actually use law of cosines, and that's what Karina, who did this problem in 5th grade, that's what she did. She did it like this. I'll just show you what she did. Equals inverse cosine. And what she did is she took 3.2 squared minus 7.
Or could you do the 6.4 over sine 56.226, and then
Yeah, you could.
the other one?
So this is
That
what,
one's easier.
yeah, and so this is what Karina did, all right? So she got angle A, and then she subtracted for the last one. But go ahead, Emily. You did law of sines, right?
Yeah, I did law of sine.
So let's go do what you did. That's really good. Okay, so you got law of sines, you got you got angle A is going to be equal to inverse sine of 3.2 times sine of 56.226, is that right?
Yes.
Over
Over 6.4.
6.4. Yeah, so angle A is equal to, it'll be smaller, and it should be smaller than this one here.
24.8.
Degrees, right?
Yep.
And then B,
Add those together and subtract the 180.
yeah, you can subtract out of there.
Something like that.
So you get, it'll be 90 something. Okay, so we have everything, right? And we are really kind of just about officially out of time. But that puts us in pretty good sync with fifth period class now. So I'm really glad about how that went today.
Are we keeping these?
Yeah, keep those.